The extrude modifier is a relatively simple tool to use, and for that reason we'll start looking at the main spline-based tools with a look at the extrusion modifier. In the real world, extrusion is a process through which some form of media is forced through a hole of a very specific shape. And this means that when the material emerges from that hole, it is forced into that shape. And this process is used to form long stretches of the material into rods of that particular shape. The materials can be things like plastics and metals such as steel, copper, aluminium, and so on. And depending on the material being used, the extrusion can be carried out on the material when it's cold or when it's molten. In the natural world, extrusion takes place in many volcanoes. You may have actually seen this on TV, where the molten rock, the magma, is forced through a cooler rock's aperture, a hole. You know, you see a hole in the surface of the rock, and you see the magma being pushed through it. And as the magma emerges, it takes on the shape of the hole through which it's forced. And the same kind of thing goes on when you do icing on a cake. You do piping. You force the icing through the hole in the end of the icing bag, and the hole may be shaped like a star, and this produces a kind of extrusion of the right shape. Now, in 3ds Max's terms, the icing example that I gave you would be a loft, and the reason for that is that it would form shapes which are curved rather than being completely linear. That's the basis of the extrude modifier in 3ds Max. So in 3ds Max, the extrusion always takes place along a straight line. And for nonlinear extrusions, as I just said, we need to look to the loft compound object. And we'll be looking at that in a lot more detail later in this DVD, as I said, in 3 separate chapters. With the extrude tool, we do not need any form of path along which the extrusion will take place, because after all, as I just said, the extrusion is always in a straight line. So basically, the extrude tool has a kind of straight line built into it. It always does the extrusion along a straight line. The surface produced by the extrusion modifier can either be open, if you can imagine like an open tube, or it can be closed depending on your needs. This is achieved by capping the ends of the extrusion. If you don't cap the ends, what you end up with is an object that will look like it's been made out of sheet metal, like a very thin sheet metal that forms a tube, let's say, or a box. If you do cap the surfaces, then it will produce what looks like pretty much a solid object. But this is only possible on surfaces which actually form a closed loop. This is something that we talked about earlier. If it doesn't form a closed loop, you can't cap the ends of the surface because it doesn't form a closed shape that the capping system can actually work on. With that being said, with no further ado, let's actually have a look at the extrude modifier in practical use. Now, what I'm going to do here is I'm not going to show you pre-made shapes. In some cases, I will use some of the templates. But what I'm going to do is actually create the shapes so you can actually see how I create them. I think it's probably better that I actually create them in front of you, and then you can pick up some kind of workflow ideas there. So let's say we wanted to create a beveled box. I could obviously use the rectangle tool to do that, but I'm just going to do it by hand. Then we could draw a shape out here. Actually, let me change the uh, initial type of vertex to corner. There we are. I'll just draw that out here. I'm not trying to be super accurate here. I'm just doing this quite quickly. And I'm going to say close the spline. Yes. Now it's already an editable spline because it was created with the spline tool. So I'm just going to move this. So we've got a square shape here. And now I'm going to use the refine option. And I'm just going to place some vertices in here. Now what I'm going to do is I'm actually going to place one here. And I'm going to use the grid to give me a kind of guide. Now you can see this isn't actually placed on the grid here. So let me just modify this. I could have used the snap tools when I created this, but didn't want to be too finicky in this case. So we'll just edit it after the fact, put it onto the grid, and we'll just add a point here, refine here, and refine here. Now I'm just going to grab these points and move them up here to the next grid point, so we get a 45-degree angle there. Do the same here, and then I'm going to select all of these, right click, I'm going to change them into Bezier corners, and then I'm just going to zoom in here, and I'm just going to edit these and make them into nice curves. So this is not going to be super accurate, but I'll give you an idea of how you can just, put in bevels yourself. just finish off here. There we go. And if you're in a rush and you didn't want to do that, as I just said, you could always just use the rectangle tool and change the corner radius until it's the size that you want it to be. That's the easy way of doing it, and probably the smart way of doing it. But for now, I just want to hand edit everything to show you how things work. We can see that the pivot point is there. In this case, I don't really think it makes any difference to the extrude tool. So let's actually use the tool on it. It's a modifier. So let's go to the modifier panel, go down here and look for extrude in the list. I generally, when I'm teaching, I like to use a big flat list like this because you can actually display all the modifiers in sets by using this option here, show all sets in list. But I find it's easier to just do it, alphabetically because you know where it is in the alphabet, so it's always easy to find. I'll just go and click on extrude, and we've got an extrusion of 0 length at the moment. So if we just go into shaded mode, you can see that with an extrusion of 0 length, it's still actually got a shape there. It's filled in this area with polygons. If we give it some length, let's actually go up here. Now we've got a 3-dimensional object, as you can see. And in this case, these selection brackets are a little bit distracting. So let me just go in here and turn those off. So now we can see our object more clearly. I'll just press F4 to show the actual wireframe on top of the shaded. And one of the issues you can see immediately is we've got too many polygons going along here. I mean, it's not too many, but it's actually pretty wasteful. So what we can do is to change that is we can go down here. As I said earlier, this is to do with the, let's just show end result so we can make edits here. This is to do with the interpolation system. And you can see at the moment I've got 47 steps and no optimization, and we're not using adaptive. So the first thing we could try is let's try using adaptive, and you can see that's adapted, so this is a straight line, so it's basically put no steps in here. That's saved a huge amount of polygons already, but the corners are using an awful lot of polygons there. So if you wanted explicit control, I would actually go to optimize, and then you can choose just how many steps you want here, 0, 1, 2, 3, 4, 5, 6, whatever. So as I said earlier on in this DVD, 10 quite often gives you a pretty good approximation of a curve, as you can see here. It depends on the distance, to be honest, because if you're going to get up close here and look, right in on this corner, let's say, then you may need more tessellation at that point. So you could use a higher value if you wanted to. It's not going to be a killer if you use 20, let's say. Something to be aware of is that if we zoom out here a little bit, and we could go back to the actual extrude tool itself, you can see that we have this option here for segments, and that's how many segments we have along the height of the object. So let's just increase it here. And as you can see, every time I increase the segmentation value, we get more segments in height. So something to be aware of is that the steps that we have going around the spline, when turned into polygons, they get duplicated every time you add a segment. So let me just go back and show you what I mean by that. If we put the segments back to 1, we right click and we look at properties, you can see that currently we have 108 faces in the object. If we increase the number of steps a few times, the end faces stay the same, but now we've basically had basically 4 times as many polygons along the sides here. So if we have a look now, we can see that we have 332 faces. If we went back down and we increased the steps here, and let's say we turned off optimize, then you're gonna, every time you basically add another segment, you're gonna, increase the number of polygons proportionately with the number of polygons you got going around there. So that's where using optimize or adaptive really comes into play, because it can save on a lot of polygons, especially on flat surfaces like this. So let's have a look at some of these other options here. We'll just run through them in order, basically. The first thing we have is the amount, and that's the distance in units. So we could say 10 units high, 20 units high, 30, 40, 50, whatever, whatever the value is that you need. Obviously, the segmentation that you've chosen will be squeezed into that area. So we've got 5 segments. It's now going to fill that height. If we made it into 50, it's going to fill that height. So really, it's just down to you exactly what you want. The next option we've already seen, segments, how many times this direction gets subdivided. Then we have cap start and cap end, and that actually fills in the end of the shape. So cap start and cap end, as you can see. If you don't use that, then you've basically got a hollow shape. It may appear to be completely hollow here, and you can't actually see the back faces. That's just because we're not showing two sides of the polygons here. But using shaders, for instance, we could create a shader here, turn on two-sided, and apply it to the object. And although you can't really see it in the viewport, if we did a render, you can then actually see the interior faces of this object. So in some cases, this may be all you want. In other cases, it's going to look a bit silly. I wouldn't ever use it because you've got to sort of, it's a physically impossible object here because this face here is actually infinitely thin. I would actually create a surface which actually has some thickness rather than doing it this way. Well, I'll show you how to do that in a second or so. So cap start and cap end is usually a pretty good idea. For that to work, as I said, it needs to be a closed surface, otherwise the cap system can't work on it. You've got two types of cap. You've got morph and grid, and if you check out the online help, it explains those in a little bit more detail. But basically, one system is designed to produce a surface that has a constant number of vertices, and that can be used with a morph system if you ever need to do that. That would be a pretty rare thing, to be honest with you, with an extrusion. The other option is to use a grid, where it'll actually break up the surface using a grid, which makes it much easier to deform. And as I said earlier on in one of the earlier DVDs in the series, subdividing a surface to allow for deformation, let's say by using a bend modifier, is a very important thing. So that's what those two options do. Please have a quick experiment with those if you like. Then we have the geometry type that the surface is actually going to produce, and you've got three options. It can come out as a patch, that's a Bezier patch surface, a mesh, which is the default as you can see, or NURBS. So if I say patch, this is now made up of patches. So let me just show you what I mean by that. If I just copy this, shift copy this here, shift copy this here again, we can try out the three different options now. NURBS, as you can see, NURBS couldn't cap the ends. The NURBS system in Max isn't great, so, you know, and it's also flipped the normals as well. So not necessarily the best output, really. Patches, actually not too bad, really. And it's also taken into account the segmentation as well. So we can just, you know, change that. If we just put it down to 1, and we right-click and we say convert to editable patch, and go in and edit it, you can see it's actually made up of patches in 3ds Max are basically they're spline-based surfaces. So this is a triangular patch, you can see here, and this is another triangular patch, and this is a quad patch. But, you know, I basically mean it's got 4 sides to it. You can modify these control handles. It's just like a spline, you know, and you can actually change the curvature. If we look at it in 3D, you can see you've actually deformed that surface, and it's actually curve-based, so it's just like a spline. I mean, it is basically a spline. So you can modify the surface in that way. Quite cool, and certainly something to experiment with. We're not, as I said, going to be looking at it in any real depth in this DVD, but I just thought it was cool just to show you those surfaces in action, as you can see there. You actually define how smooth they're going to be by using values down here, which are the view steps. So you've got steps for the viewport. You can see it's a little bit crude here. We've got not such a good level of segmentation there. Well, we can change in the viewport by changing that value. But generally in the viewport, you probably want to keep it quite low. And at render time, you can have a separate value. So you can say at render time, it uses 20 segments. In the viewport, it uses, say, 4. So it looks pretty crude there. But when you render it, you get this nice, smooth, curvy surface. So as you can see, the extrude tool can output in 3 different formats: patches, NURBS, and the best format, which is mesh. Then we have options that are basically to do with smoothing and material IDs and mapping. Generate mapping coordinates. In other words, does it put UV coordinates onto the surface? As you can see, by default, that's turned on. It's quite useful. Generally, you want it on. But if you have a surface that's never ever going to be mapped with anything that needs mapping, turn it off, because then it doesn't actually apply the UVs, and that saves a little bit of memory. But generally, you probably want your UVs to be there just in case you need them, so I would leave that turned on. Generate material IDs, that was something that we looked at in the second DVD in this series where we looked at meshes. Generally, material IDs are a good idea as well, and what it does is it applies separate material IDs, I believe, to the top and the sides and the base surfaces, so you can apply different materials to each one of them. And then this other option here, basically, that will inherit the material IDs, which you can actually apply to the segments of the spline. So you can go down here, you can select one of the segments, let's say this one here. And if you go down here to the bottom of the rollout, you can see you've got material IDs. You could set that to being, say, 2. You could set this one here to being 3. Set this one here to being 4. Just come out of here. Let's quickly make up a material where we can demonstrate this. So let's go for multi-sub-object. We need a few materials here, so I'm just going to change these color swatches so we can see a difference between the different IDs. There we are. And now if I apply this to the surface, we'll turn this on and just click on the surface, use shape IDs, and you can see now that this and this surface have different IDs and this surface. That's because they basically inherited along the direction of the extrusion, the actual IDs that I specified in the spline. If I turn that off, you can see that we've got a blue base, red side, green top. So it's basically placed different material IDs on each surface of the resulting extrusion. And the last option is, do we have smoothing turned on or turned off? Generally, you want it turned on. If you get rid of the wireframe now, you can see that this is actually not smoothing, so you can see the actual segmentation. We can turn smoothing back on, so we've got nice Blinn or Phong smoothing on the corners. If we don't want to put smoothing on, we can just leave this off and apply it later using the smooth modifier, or we can go in, edit it as a mesh, and apply it by hand. So those are the basic options of the actual extrude modifier itself. Let me show you this shape. We'll edit this shape a little bit more, and I'll show you a few variations of what you can do with it. So as I described earlier, we could actually give this, turn this into a kind of hollow tube, but to do that I would use the outline feature, which is something we looked at earlier. I'm not going to do it very far, just to there. I think that's fine. And now if we turn on end result, there we go. We've just extruded that out, and as you can see, we've created a nice kind of hollow tube here. We could, if we wanted to, we could add shapes to it. So let's create, say, a circle here. And a circle here. I wouldn't have them overlapping because that could cause problems. But as an example, we could just move this here, move this circle here, and let's just change the radius of this one, move it here a little bit. What I'm going to do now is I'm going to go down here to the line and I'm going to attach these in here. So let's attach this one. And you can see immediately it becomes part of the spline and becomes part of the extrusion as well. It's procedural. And if we turn on wireframe so we can just see the other one, we'll just add this other one here. And you can see now that it's become an interior space to this, what looks like a cylinder is now a tube. Now if I go into sub-object mode, let's try actually moving things around here. Just turn off attach. We'll just select that spline there. We'll just move this. And as you can see, as it pops to here, it doesn't actually describe an interior surface anymore. It becomes a cylinder in its own right as it moves in there. You can see it's a pretty cool tool, quite intelligent in the way that it works. It basically looks for shapes that define an entire surface, and then if it finds another shape inside which is closed, it then sees that as being a negative space, as it were. And then if you put another closed space inside that, it sees that it's a positive space. By positive, I mean that it's a solid shape. Negative, it's a hole. So it's a pretty cool, intelligent tool, you know, in that respect. We could, let's say, we could just get rid of these splines again. We could get this surface here. Let's make sure we've got that selected correctly. Yeah, we have. We could scale that. I'm just going to scale that in 2 dimensions. Scale that inwards here. There you go. So we could change the size of this if we wanted to. And let's say we wanted to create some square holes along here. Well, we can hold down Shift. We'll just change to move mode. Just going to hold down Shift and move. That's copied that spline at the same time. And as you can see, it's basically seen that as being a positive shape. Now what I'm going to do is I'm just going to scale this down on 2 dimensions. Scale it down here. And then what I'm going to do is I'm going to move it until it's inside this wall here. When it gets inside, it sees it as being a negative space. We can just move it down here. And now, if I wanted to, I could add a few of these. I could just hold down Shift and make a hole here. Shift and make a hole there. Make another hole there. And you can just put holes in that extrusion. It's a very, very cool system. I think you'll agree, yeah? So that shows how we can create some shapes there. If you use as an example, the text tool, we could create some shapes here, which are a little bit large at the moment. But let's say we wanted to put a label on here, a 3-dimensional label, geometry. Well, let's say we say CG, oops, lowercase, let's do uppercase, Academy tool box. There we go. Just make it a little bit smaller. And we'll move it into position here. And then we'll move it up here till it's roughly on the surface. You can see it's still a little bit too large at the moment, so let's just make it a little bit smaller till it actually fit on the surface here. There we go. Doesn't have to be perfect. Just move it up a little bit. And now what I can do is if I just go into wireframe, there's the text. Actually a bit messy looking, so we'll just center the text. There we go. And what we'll do now is we'll get this extrude modifier and drag it and drop it onto the spline. Now we have an extrusion of the text, as you can see. It's pretty huge. We don't really want it to be that size, so let's try extruding it 1 unit. Yeah, that's looking pretty good. Maybe a little bit too big still, so let's say 0.5 of a unit. And we certainly wouldn't need 5 segments along the height. We just go into wireframe mode, you can see we've got 5 segments there, which is completely overkill, so we'll just put that to 0. There we go. And now we've got some nice 3-dimensional text there on our box. Pretty cool, eh? So let's have a look what happens when we create shape here and we don't close it, just out of interest. Are we going to get any kind of freaky behavior, or is it going to work fine? Just make it smooth and put some Bezier handles on here. And what I'm going to do now, I'm going to do the same as before, grab the extrude modifier, drop it on here. And as you can see, no, it's not going to freak out. It's absolutely fine with that. But what it's basically created is an open surface. Now, something to notice is that cap start and cap end are on. And it's not going to do anything, and it's because it's an open object, so you're not really going to get any caps there. If you want caps, you're going to have to close this up here. But this means that this is a really great tool for also doing architectural work with, because in this case, you know, this may not really make that much sense, but let me say, you know, let's say we have a floor plan and we trace over it using splines and snaps, and we basically create the walls of a room. I'm just going to create a really wonky looking wall here. There we go. Yeah, I wouldn't want to live in a house with walls like this. So thank God I didn't go into architecture. But let's say that was the floor plan of some walls in a building. We can extrude that as well, and that's a perfectly valid extrude. So let me just show you that. Pop it on there. There we go. We've got our walls. You can see it's actually inside out, as it were. And I think that's to do with the surface direction of the actual curve. So what we can do is we can try turn on show end result. Let's try and find our end point. It's down there. Let's try actually reversing it. So let's try selecting this one and make first. Yeah, as I thought, when we did that, it changed the direction of the curve, and it basically made the outside of the wall inside and vice versa. So again, there's a circumstance where the first vertex in the curve has a big result on the end shape that's actually produced. So you can see it's a really great tool. You can create these nice 3-dimensional boxes, cylinders, tubes. You can create 3D geometry, text, as you saw here. You can create these sort of almost like sheet metal shapes here. And you can create the walls of a room if you wanted to. The really, really cool thing is, if you then found out later that the architect had changed his mind, and that very often is the case, you can just go in and you can modify the walls. You can just move this wall here. Let's say they decide to add a little alcove here, then you can just go in like this, and you can make the alcove. Oops, still got refine on there. Just grab that, move there in there. Now we've got our alcove in our room. The extrude modifier, although it's actually very simple, is very flexible, very easy to use, and it's very powerful. And you can see that if you try to model some of these objects using polygons, and in DVD4 we'll look at sub-Ds, but even with sub-Ds, creating these objects with polygons would be, it'd be crazy. You at least want to start off by using the spline tools, extrude, and then work from there with the polygon tools. So that's it for the extrude tool. Very cool. Please experiment. Try out some of the things that I've shown you here, and you'll see what a great little tool it is. Let's move on to the next chapter now, where we'll look at the lathe modifier.